Do you hear me? Out there as well? Perfect. Okay, brilliant. Really nice to see you all here tonight at Foo Café's 12th anniversary. And what you're going to say about that? Yeah, been doing this for 12 years now, and it started up like a crazy idea to do a conference every day, year round. And actually no one believed me that I could do that, and not even my mom. So, but here I am, and my mom is still surprised that her lost son were able to do anything so in life. But so what we do here is actually we just come together. Like I love geeks, that's important. Really like people that really passionate about all kinds of software development. That's why I invited Björn Regnell today as a speaker. Total geek. I love it. So, what we do here is we learn, we create, and we share. And we will all grow by doing that. And of course, we're also networking. Of course, that's an important part. And don't be afraid to talk to someone you don't know, because everybody here is here because they would like to be here. So, otherwise, they will be watching football. Someone told me that there's a football match tonight, and we don't care. All right? All right, so as you know, we have been here now for 4 years at Go to 10, and we have a really good collaboration with Internet Stiftelsen. So we are doing events here in Malmö and in Linköping and in Stockholm. And we are really grateful for this collaboration. It works out really, really well. And yeah, this is a nice venue, don't you think? Yeah. Yay! We, our first 8 year, we were at Media Evolution City, and still there are people who are going to Media Evolution City when they go into Foo Café events. But we moved here 4 years ago, all right? But people are coming back, even though it takes like 4 years to come back. They do, and just because we do things that we love to do. And I have my colleague, Laura. She is the tech expert in the firm, and she is taking care of the live stream that we are actually on right now, I assume, in a way. So, oh my God. Billions of views on YouTube, yeah, incredible. All right, so the reason why we are able to do this is that we have partners. We have companies that supports us. And the majority of the companies are tech companies. And like 4 years ago, before the pandemic, this list was, yeah, many more companies. But still we are able to attract some companies that supports us. And thanks to those companies, we are able to do what we are doing. Providing good tech events is interested in the same topic, and you can learn from everyone who's attending the event. And that's the key. The key is to learn from each other. And that's what we do here. So it's easy peasy. So, and our big supporter is Capiche. Where is Anders? He left. Oh my God.
He couldn't handle all the credits he got.
All right. So, all right. Anyway, so that's a good company that supports us in many years. Anyway, there are many other companies here. You can see the list, and there are also non-tech companies like Wihlborgs. Wihlborgs are the real estate that has this building. So, and they like what we are doing in their buildings. So that's why they are supporting us. And of course, the city of Malmö. The city of Malmö, the municipality, are super cool. I think this is the best city by far in Sweden. Sorry, Luma. So.
I was born in Malmö.
Yeah. Yeah. So, and also thanks to, because they also providing good content, is all the user groups you have. that comes here and do events like, for instance, Azure Skåne. We have Nikos over here, over there, yep. And we have Dennis, who runs a new group, the Malmö AI Devs, and so on. And so they provide good content just because they are passionate about it. And that's what drives Foo Café, is passion. All right, so the topic of this year that we have had, maybe it's not really a surprise for you, but it is AI. Yeah. Oh my God, yeah. What is it? I will explain that for you. Because on tonight's topic is very much on AI. And this is so complicated, so I have to have paper to read from. So, this is a philosophical reflection on AI. Right? Are you with me? Mm. All right. Prometheus and the ethics of creation. Prometheus, one of the titans, 8th century BC, that's almost 3,000 years ago, is a metaphor for human creativity and the risks of wielding power knowledge. In Greek mythology, Prometheus defied the gods by giving fire to humanity, symbolizing the gift of knowledge and technology. There is a parallel between Prometheus and the creation of AI, Mary Shelley and the fear of artificial intelligence. So Mary Shelley wrote Frankenstein 1818 as an exploration of the dangers of creating life. It's to illustrate the moral and ethical dilemmas of creating artificial beings, drawing a parallel to AI and the potential of unintended consequences. The novel serves as a warning about the hubris of playing God, a theme that resonates deeply in the context of AI development. Ooh, deep shot. So then we have, of course, Alan Turing and the definition of intelligence. Alan Turing was often considered the father of AI, introducing the Turing test 1950 as a way to define and measure machine intelligence. Turing's contributions to AI emphasize the ongoing debate about what constitutes true intelligence and consciousness. Turing's work challenges us to consider whether machines can ever truly think or if they are merely simulating thought. As a conclusion to this, the intersection of myth, literature, and science, so of AI is not just a technical challenge, but also a profound ethical and philosophical journey. As AI continues to evolve, these historical and cultural reflections provide valuable insights into the potential consequences of our creations. Ooh, that's super deep. Huh? So, thank you. That was my part of the presentation. And for the main speaker, we have Björn Rignell, professor from Lund University. And he's very kind to prepare this talk in the middle of the start of the semester, which has been, not funny, I assume.
Well, it's always funny when the semester starts because I'm looking forward to 200 plus new of you. They are coming on Monday. So.
Yeah, brilliant. So let's swap computers.
Yeah, technical glitches. Can you hear me? Is it too loud? Is it okay? Is it perfect?
So shut up. This one is just not funny.
And I need the HT. Oh, yeah. We don't want champagne in our computers.
Du kan hålla i det.
So.
Do we have tech? Yes, it should be. Ta-da!
No, it's working, it's working. So I'm hoping I'm not speaking too loud. It's kind of work damage. I have to speak in big lecture halls. Thank you so much for inviting me, Mikael. I just love Foo Café, so I couldn't turn it down when he asked me. And he also gave me the topic, actually. The future software engineer. I'm supposed to tell you what junior and other software engineers need to stay relevant in this new area of AI-boosted software engineering. We will see, we will see. So short about me, I'm professor at the Department of Computer Science, just like 20 kilometers north of here. I have been doing software engineering for a long time. I started doing research in software engineering in the 90s, and I've also been teaching a lot. And since 2015, I've been responsible for the introductory programming courses for the IT programs at LTH. And I'm also very proud to be a member of the Scala committee, who is governing the future of the Scala language, which I happen to use as a beginner language for stay relevant. Everybody's asking this. Will AI take our jobs? In February, this guy, I have a picture here of Jensen Huang, who is the big boss at the company who sells the super expensive AI chips who heat the planet as we speak. And he said, nobody has to program. Okay. So I guess we're doing prompt engineering now. This full course is 41 minutes. You can learn how to do software engineering in 41 minutes. What he actually said was kind of contradictory, because first he said, nobody has to program. And then he said, everybody will program. And he redefined programming as using his AI chip to do chat prompting to do the coding. And this is what everybody will do. So everybody will program, but we redefine programming to what is a human language. You know, this language that we use, this ambiguous, error-prone language. So that's the idea of, and YouTube kind of flooded with videos on death of programming. So I mean, of course it's really relevant to use AI as a tool and to be able to do these things that we now call prompt engineering. What's that? It's like when we struggle with a large language model to get it to give us some useful output, and we need to ask and ask and ask and ask again. And actually, here is an academic research paper from friends in Gothenburg that have studied how to use AI in a specific task in software engineering, namely requirements classification and automatic requirements traceability. So they have tried different strategies for prompting, and they are using the API to a large language model, and they tune the temperature. Do you know what the temperature is? It's how random the output will be. So you can tune the model and get more or less random results. And if you want help, because it's tedious, you know, all the requirements, where do we have them? In issue trackers all over the place. And we need to classify them, and we need to prioritize them, and we need to trace among them and things like that. And that of course, and it has been a long tradition in requirements engineering research way back to try to use these AI techniques to help the humans in kind of a collaborative mode. So it's not that the AI is taking over the human job, it's the collaboration between AI and humans. And let's think back for a bit. This is a paper from 1957. It's about Fortran, an ancient programming language that is still live and kicking. Fortran programmers are actually pretty well paid today. You've read that paper. Then you have also read the things that So it's not just to sit down and code, it's all the other things that we do, requirements, tests, thinking hard about how to solve it. Of course, software architecture, everything we need to do. It's not just writing the code, of course. But when this came, telling about the automatic system for programming, relieving us from doing assembler coding, all the assembler coders said, oh, the compiler will take our jobs. Compiler will take our jobs. It didn't happen. The assembler programmers are still quite well-paid engineers because sometimes you need to do it, but we still need to understand, of course, the different layers of abstraction, so nothing is going away, actually. And what are we doing constantly as software engineers? We are pushing the limits, and our best tool is abstraction. So what over the history has happened is that we invent this abstraction like compilers, and then we start to use it and do even more complex systems. And they get so complex so that we hardly can manage them. And then we need to invent even more powerful abstractions. And on this cycle goes, and we, as soon as we can, we will push the limit with even more complex systems. So, of course, this is about developer productivity. We want to do things that are boost our productivity. This paper is from researchers at Google. Sierra Jaspan was invited as a speaker at my department a couple of weeks ago. And she was explaining this. Google is kind of special because they force every engineer to use exactly the same tools. And they measure everything. I'm sure they know exactly when everybody walks away to the loo or whatever. Or when you save a file, or I don't know exactly what they measure. But they measure a lot, and they try to use their tools to boost the productivity of the developer. And the interesting thing is that when they investigate, it's notoriously difficult to measure productivity. If you just measure number of lines per hour that the software engineers produce, then you will get a lot of lines of code per hour. But it will not be good code, and it will not do what we want. So it's not about, it's not very easy to measure this. But when the Google researchers dig into this, and they use a lot of surveys, and they have self-rating of productivity and coding quality, etc., they see this kind of interrelated things that are correlating productivity, the work environment, and code quality. So the causal relationship here are kind of blurred. We don't know exactly what causes the other, and they are probably kind of supporting each other. So we need a good working environment. We will want to work with high quality code, and then we can produce high quality code, and our productivity is linked to all of this. And defects get more expensive the longer they stay. So here's a principal picture of what happened. Assume that we find, or that we introduce a defect already as a bad requirement that keeps lurking along. Then this defect will cost a lot if we don't fix it as early as possible. So what we need to do, and this is still relevant, never with AI or not, we need to focus on the high quality requirements, architecture, design, and all of the things that we do in software engineering, of course. Otherwise, the cost of defects tends to grow even exponentially if they stay long. So also, I think that when we are using AI to try to address productivity, of course, we can have use for machine learning, but there are also problems with machine learning. So here is a list of machine learning problems, and the strange thing is that people talk about AI now, and they mean machine learning. It's like a sub-discipline of AI, but AI is much more than machine learning, and people seem to tend to throw machine learning at every problem currently. So, but the training process is actually relying on randomness. So the emergent behavior will be kind of non-deterministic. And suddenly you can get things like hallucination might be biased, and then we will have biased models, and so the face recognition will only work with few errors for white males, maybe. And we can overtrain, which means that there is an overfitting, so that the ability for the model to generalize will be bad. And the training process consumes a lot of energies with a lot of expensive chips. And actually, if people look at other parts of AI, I will call it symbolic AI, like not trained AI, you might very well be better off using another AI technique than machine learning with less power consumptions, etc. So one example is, for instance, in a modern programming language, the type system can be viewed as a proof engine. So the compiler helps you to find bugs with a kind of a very sophisticated proof engine that runs while you compile your program. And way back we would have called that AI, but I guess that compiler engineers don't want to call it AI anymore, because then you get all these connotations of, so AI is suddenly really in some context starting to kind of be a word with some negative connotations, like it's you cannot rely on it and it will hallucinate, etc., etc. So yeah, I think there are problems with the training and with the data and all of that. And also, if we look at safety critical applications, it's really important that we can explain what is happening. And I think that the machine learning that is used in safety critical applications that might kill people, there you need to contain it. And maybe then we need other techniques than machine learning techniques to contain the machine learning and so that they don't kill people. And also we can see that because it's so expensive to train these big models, the monopolization by big tech over this technology is rapidly increasing. So I think there is a risk here that you need to be very, very powerful in terms of capital to invest in order to stay in the race if we do it like this. So my predictions now, Mikael told me in Swedish, don't be afraid to killgissa. But by preparing this, I will try to make it just not random guesses, but I have some idea behind all of the points here. But I don't think AI will steal the jobs. Not for junior software engineers, not for senior software engineers. But I think AI really can help us in this abstraction complexity cycle if we use it right. If we find specific applications, maybe AI eventually can help us really raise the abstraction level. We'll see what happens. I think that it can, if used right, eventually make us a lot more productive and help us create more complex system, of course, but it will create a lot of bugs. So we will also keep the senior developers busy with finding the bugs that the junior developers introduce because they copy-pasted from ChatGPT. No, well, that's not how we're supposed to work. So it might, if done right, enable us actually to finally do away with this nitty-gritty, low-level, error-prone boilerplate that we are doing. I mean, still the tools we are using, there are still these kind of nitty-gritty boilerplatey things, and maybe we can get relieved from that. But and start doing even more of the fun and difficult stuff. So that's the bright message here. I think, what are the fun and difficult parts? Yeah, that's things we do, like getting deep domain knowledge, understanding all the different types of users and what they want, do good requirements prioritization, product management, do the difficult quality trade-offs involved in software architecture, so that we can have systems also that are less heating the planet. We can invent new things, new abstractions, like new cool modern programming languages that are more safe. We need the safety so that we don't get the pasted bugs from ChatGPT. We don't miss them. We find them. And new abstraction mechanisms. So that is kind of the bright message that I hope symbolic AI. Because I think that we will need that in order to contain the problems that the machine learning AI has. And actually there is a really interesting article in Wikipedia on symbolic AI, which gives you a history expose of all the eras in AI research with all the AI so-called winters. What is an AI winter? It's when the hype had turned into disappointment and everybody says, oh, AI is just crap. And the university researchers get problems with funding. That's not the case now. Our AI researchers, they have problems with using all the money they get. So they're hiring people that can research for the money that we get in this particular ML part of AI. But symbolic AI, what is that? That is made with normal, explainable, reliable code that is kind of smart, that does human-like things, but with an understandable algorithm. So you can look it up if you haven't seen it before. It's things like constraint programming, logic programming, search algorithms, SAT solvers, automatic proofs, expert systems, automatic planning and scheduling, all of these things. And nowadays, we may even not always call it AI because they are their own subdisciplines. So check that out. I think that we will need, for every line of code that is devoted to machine learning, we'll need a lot of code around it to administer it, to train it, to facilitate it, to check it, etc., etc. So it will, it will be a challenge, especially in safety-critical systems. And also AI will be regulated. This is a paper from colleagues of mine at Lund University about the coming AI Act. So if you haven't heard about it, you should check it out. What will this regulation mean? It will mean that you will have to write more code. We need to implement features that enable us to be accountable and transparent in how we use AI. And the EU will check you. So I was asked by Mikael to help the junior engineers to understand kind of what do they need to know in the future. And I made a list here of typical things that are common knowledge in software engineering. Things we teach at Lund University, of course. Algorithms, data structures, architecture, concurrency, requirements engineering, usability, testing, configuration management, discrete mathematics, calculus, linear algebra, that's another name for machine learning. Operating systems, compilers, security, networks, web programming, full stack, etc., etc. This is what you get, understand them still, to be able to use AI in a good way. And I've pasted in the presentation that will be available in a link, and we will email the link to the presentation. I've pasted the course plans for 3 of our IT programs at Lund University. And you can study at Chalmers and KTH, and also in Malmö soon. I've heard a whisper from the dean there that there will be a 5-year master program in IT also at Malmö University. So my first advice to stay relevant and get the best job is to get a good degree. Get a good degree. There are very many out there who can get a job, who has maybe or is self-taught or has a short education. Everybody's needed. But it's the ones that have the deep knowledge of the foundations that will really be the motors for onboarding all of the brains that are needed for planning the whole endeavor, for making the hard decisions on what tools to use and what requirements to prioritize and things like that. So get a good degree and you will do the fun and difficult stuff. I also recommend that you really try to learn a little bit about how AI works. I'm going to dig into it deeper. But I've made a little repo here on GitHub where you can play around with a very small neural network. It's less than 200 lines of Scala, and it's very simple, from scratch, no dependency neural network. And you can play with it and you can train it with data that is biased, and you can see how bad it gets and things like that. So it's kind of fun. So you can try that out. But I think it's important to understand what is happening underneath in order, if you may remember the long list of deficiencies I talked about in machine learning. In order to address this, you really need to know what is going on. And my guess here is that there will be a resurrection of symbolic AI around the next AI winter maybe or so, we will see. So maybe you want to check out those techniques that are kind of normal code that do smart things. And check out the AI regulations and its implications. New features, more code, more bugs, more jobs. And learn a safe and powerful programming language, because if we are going to use large language models trained on code, we want them to be trained on code that is safe. Of course, I'm biased here. I'm part of the Scala committee. So I think that one of those modern cruel languages is, of course, Scala. So you should check that out. And I felt really, when I discovered Scala and started coding with it, I felt really productive. So it was really fun. And now Scala 3.5 is out with a new runner that makes it super simple for beginners to get going. And I think I'm going back to the, how much time do I have left? You will stop me when I've gone too far. Okay, so I will go back to the, if you remember the Google engineers I was talking about. They made a natural experiment. Well, they didn't, the coronavirus did. So during the pandemics, there was a natural experiment. What happened to developer productivity? Everybody were pushed home. We couldn't talk to each other. So in the beginning of the pandemic, their measurements said that the productivity went down. But then it went up. And they tried to dig into that. Why? And then the pandemic ended, and the productivity went a bit down again. Why was that? Well, one of the explanations is that after a while, the bosses, many of them senior software engineers, realized that they needed to convey the big picture much more clearly. So they spent a lot more effort on explaining the why, the big picture. And not only to their sub-level in the management hierarchy, but to the so-called skip level. Namely, they talk to others than just their closest underneath, so to say, in the hierarchy at Google. So there was a lot about communication of what was the purpose, where are we heading, what is the roadmap, what are the prioritized requirements, why, what is the end user perspective, things like that, the why. And that actually boosted productivity. And then when the pandemic ended, the bosses went back to the normal behavior to some extent. And the productivity went a bit down. I think that's really interesting. So I urge every one of you to actually take responsibility for understanding the why and the big picture. So even if your boss is not as good as explaining that to you, or your boss's boss, or your boss's boss's boss, I don't know. But you yourself at least can make an effort to try to get this picture of why, what is the general purpose, not just my little corner or box here, but the bigger picture of what you're doing. That is really important, because then you will be able to do the good decision making and the good quality trade-offs. And that is one of the keys of being a productive software developer. This is also known as requirements engineering and software architecture and quality trade-off and software quality and things like that. And also, one advice is to choose your employer wisely. What is important from an employer recognizes this and gives you time for this and gives you challenges, cool technical challenges, engineering challenges, but also with a mandate, and also involves you in the higher level decision making, and also an employer that is ethical. I think this will be more and more important. There is a reason why EU wants to regulate AI, because there are so many risks of building Frankenstein's monster here. So we will absolutely need a lot of ethics in our workplace, and your employer and the ones with the funding and the money, etc., needs to really think about the ethics around how we apply software engineering in our society. That is the end of my talk. Thank you. I'm happy
Thank
to
you.
stay to mingle
Oops,
later.
sorry.
Oh, don't ruin the chords.
Yeah, all right. Thank you, Björn.
Thank you.
And I thought, since you are working in the university, I thought you should do some marketing for Foo Café.
Oh, I'd be happy to.
Yeah.
I love Foo Café. That was how I started my presentation. I love Foo Café.
And when you are sitting at meetings with your, the other professors, you have a notebook.
Ooh. Analog notebook.
Yeah, of course. Yeah, I'm really.
I have my glasses over there. If you want to.
So I forgot to bring out a toast to everyone. Thank you for being here. We at Foo Café and Björn as well, we love you. You know that. Okay. Cheers.
Cheers. Happy anniversary.
Thank you. And the thing was that my talk was actually from a book, Artificial Intelligence and the Design of Expert Systems. I bought that book in 1990. All right, yeah. So, and actually the story I told you about Prometheus, Mary Shelley, and Alan Turing, it's also on the Wikipedia when you Google artificial intelligence. So, and the talk was written by ChatGPT. So you know, all right? No, I couldn't. That's why I have to read it out. So, and thank you very much for being here. Please stay. There are more beverage. There are more food, and I'll be back.
See you.